Good morning, students. Myself, Mantesh. After a long time, finally we are back to classes, but not regular classes. We are meeting you via online classes. You know why we made these arrangements? That is due to the pandemic, Corona. Okay. Hope you all are safe. Without wasting a time, directly I will move to the concept. So now today I will start 10th standard science syllabus. Before that, I will just revise what you had studied in your ninth standard. In ninth standard, first we studied motion chapter. In motion chapter, you have studied what is motion, what is rest, and how both motion and rest are related to each other. So later you have studied what is the displacement and what is distance, and we solved some numerical problems related to distance and displacement. Later we have studied uniform motion, non-uniform motion, and velocity, speed, average speed, and also we have studied whatever the essence of essence of speed, average speed, and velocity. That is meter per second. We use this meter per second to measure average speed, and velocity because we know the formula for speed. Speed is equals to distance by time. We measure distance in meter and we measure time in seconds. So that's why the SI of speed is meter per second. Later we studied about the acceleration. You know what is acceleration? The change in velocity with respect to time, or the rate of change of velocity is called acceleration. And we studied the extent of acceleration, that is meter per second square. Later, we have studied about graphs. You know, we can represent the motion of an object graphically. First, we studied distance time graph for uniform motion and non-uniform motion. Later, we have studied velocity time graphs for positive acceleration and negative acceleration, and increasing and decreasing velocity. At last, we studied uniform circular motion, and we solved some numerical problems. Okay. Then and we have studied important three laws, three formulas. That is, V is equals to U plus AT, and second one, S is equals to UT plus half AT square, and third one, V square is equals to U square plus 2AS. We call these here equations of motion. Here V represents final velocity, and U represents initial velocity, and here represents acceleration, and T represents time, and here S represents distance or displacement. Here the first equation of motion, which gives the relation between velocity and time, and the second equation of motion gives the relation between distance and time. Then the third equation of motion, which gives the relation between velocity and displacement. And we studied about important derivation, that using velocity time graph. Hope you remember this graph. Okay, we have proved all these three equations using this velocity time graph. Okay. Next, in the second chapter, we had studied the cause for change in velocity. See, to change in velocity or to change the direction of an object, the force is necessary. Without force, we can't change the direction of an object, or we can't bring objects from motion to rest to motion. Okay, so here the force is essential. Next, we had studied about inertia. Inertia and the first law of motion. Okay. Later we had studied about the momentum and the second law of motion, and also we derived expression for force, that is F is equals to ma on the basis of second law of motion. So later we had studied Newton's third law of motion and law of conservation of momentum. At last, we have discussed some problems using F is equals to ma formula and law of conservation of momentum formula. In the third chapter, we had studied about universal law of gravitation. Already you know that statement: in this universe, every object attracts every other object. That force of attraction is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Hope you remember this formula. It is F is equals to G into M into M divided by D square. Here G represents universal gravitational constant, and capital M and small represents masses of the objects, and D represents the square of the distance between them. Later we had studied the importance of the universal law of gravitation. Then we studied what is free fall, or when do we say that objects are in free fall? When the objects are under the influence of gravitational force, we can say that those objects are in free fall. So later we discussed the difference between mass and weight. Then we studied about pressure, thrust, and Archimedes principle. Then why objects floats and sinks. We are studying this much in gravitation chapter. So later we studied about the energy and its forms. In energy chapter, we studied what is potential energy, what is kinetic energy, and we derived expression for both the potential energy and kinetic energy. So I will give the expression: potential energy is equal to m into g into h, and kinetic energy is equal to half into m v square. Okay, already you know the derivation. Later we have studied the law of conservation of momentum. You know that statement: energy neither be created nor be destroyed, but we can convert one form to another form. Next, in the last chapter, we had studied about the sound. You know how sound propagates, types of sound, and the speed of sound in a different medium. Just imagine if you make this room as a vacuum, then you know the speed of sound is completely zero, because to travel sound it requires medium. If there is no medium, then the speed of sound is completely zero. Okay. Then later we studied the ranges of sound. Ranges of sound. First one studied infrasonic sounds. If the frequency range is below 20 hertz, we can call that is infrasonic sounds. If the frequency range is between 20 hertz to 20 hertz to 20, 20 hertz to 20 kilohertz, then we can call this the human audible range. Next, if the frequency range is above 20 kilohertz, then we can call those that is ultrasonic sounds. Then at last we studied the applications of ultrasounds. So this much we are studied in 9th standard. Hope you all remember these things. So now I will start actual syllabus. Okay. See, before saying that chapter name, I will give some clues. You can guess which chapter today I am going to deal with you. Okay, yes. We see variety of objects in the world around us. Okay, we can easily differentiate different types of colors, different types of plants, and we can easily differentiate different things. Okay. But we are unable to see the things in the dark. Just imagine, consider this room as a dark room. I am here and you are sitting in front of me. Okay, all the lights are turned off. I think here I am not able to see your face. Now I want to see your face. How can I see? Yes, that is because of light. Here, light is necessary. Without light, we can't see the things. Hope you got an idea which chapter today I am going to deal with you. That is light. And right, reflection and refraction. Okay, I think you have a little bit idea about light. What is light? By observing optical phenomena or nature, we may say that the light it seems to travel in a straight line. But when you place an object in the path of the light, then it bends. It may undergo reflection or refraction. We'll study that later. Okay. First, we can call light is also a form of energy. Plants carry out the photosynthesis using light energy and they prepare their food. And in the solar cells, the light energy is converted into electrical energy. So due to these reasons, light has all the characteristics of energy. That's why we call light is also a form of energy. Next, in this chapter, already we have studied about the reflection and refraction in your 7th standard and 8th standard. So, but now here we are going to in detail. Okay. In this chapter, we are going to study reflection of what is the reflection of light, what are the laws of reflection of light, and reflection of light in a plane mirror, and properties of plane mirror, and reflection of light in a concave and convex mirror, and uses of concave and convex mirror. Then we are going to study what is the refraction of light, and refraction of light in a glasses lab, refraction of light in concave and convex lenses. At last, we are going to study power of a lens. So now we will study one by one. First one, reflection of light. See, what makes the things visible? Because of light, we can see the things. But here, I can see your face and you can see my face. But here, what is the action takes place here? Yes, that is because of reflection of light. Okay, we can see the things because of reflection of light. Then, what is reflection of light? See, it's a simple. The bouncing back of light is called reflection of light. What is that? The bouncing back of light is called reflection of light. For example, if you pass light to this wall, what will happen? It undergoes reflection, means it reflects. Okay, and already we have studied the laws of reflection of light. The first law, it says that angle of incidence is angle of incidence is angle of incidence is equal to the angle of incidence is equal to the angle of reflection. The first one, what it says, the angle of incidence, sorry, angle of incidence is equal to angle of reflection. What is the meaning of this statement? See. Now, just imagine this is a plane mirror. Okay. Now, I am passing a ray of light to this mirror. Okay. See, now this ray. Okay. We can call this ray as incident ray. What's that? Incident ray. And see, now this ray it strikes here, right? At this point, right? See here at this point, I will draw one line that is perpendicular to the reflecting surface, like this. Okay, and we call this as normal. Okay, and remember one thing here. This normal is always perpendicular to the reflecting surface. Okay. Next, when you pass light to opaque object, it reflects back, right? Yes. Now it reflects like this. Okay. See now. We call this as incident ray, and this is reflected ray, and this is normal. Now observe here. The angle between incident ray and normal, is called angle of incidence. Okay, the angle between incident ray and normal is called angle of incidence. And here we use small I to represent angle of incidence. Okay. Next, the angle between normal and reflected ray. The angle between normal and reflected ray, okay, is known as angle of reflection. Okay, and we use small r to represent angle of reflection. See, what is the first statement here? Angle of incidence is equal to the angle of reflection, which means that is angle of I is equal to angle of r. Suppose I am passing a ray of light at say angle of incidence is 30 degree. 30 degree. Then what is the angle of reflection? Even that angle of reflection is also 30 degree. Okay, suppose this the angle of incidence is angle of incidence is 45 degree. Then what is the angle of reflection? Yes, the angle of reflection is also 45 degree. Okay. So hope you got an idea of what is the first law. What is the first law of reflection of light? What it says, the angle of incidence is equal to the angle of reflection. Okay. Next go to second statement. See, second statement states that incident ray, normal and reflected ray. Okay. Incident ray, normal and reflected ray all lie in the same plane. What is the meaning? Just imagine this is a table. Okay. Okay. So now just imagine this is a table. Just imagine this is a mirror. Okay. Now see, this is a table. This is a mirror. Now I am passing a ray of light like this. Okay, in this direction. Okay, and where we should draw that normal? At the point of incidence. Here, see, this is incident ray, normal. And what about reflected ray? It reflected here. Okay, see, just observe all the lines are here only, right? In the table only. Okay, so that's why we can say that the incident ray, normal and reflected ray all lie on the same plane. For example, if you pass a ray like this, the reflected won't come this side or it won't go this side. Okay, if you pass the reflected ray like here, then you will get the, if you pass incident ray here, then you will get the reflected ray here only. All the rays lies here only, right? So that's why we can say that incident ray, normal, and reflected ray all are lying on the same plane. So this is the statement of the second law. This is the statement of second law of reflection of light. Okay? Yes. Okay, so now I'll ask one question. Just imagine this is a reflecting surface, okay, a plane mirror. Now I am passing a ray of light. I am passing a ray of light perpendicular to the reflecting surface. I am passing a ray of light perpendicular to the reflecting surface. Now here, what is the angle of incidence and what is the angle of reflection? Okay, see what is the definition of angle? What is the angle of incidence? The angle between reflected ray and normal. Okay, and what is angle of reflection? The angle between normal and reflected. So now here I am passing a ray of light perpendicular to the reflecting surface. So my question is, what is angle of incidence and what is angle of reflection? Yes, see here. Now, how to draw normal here? You know, see, we usually will draw normal at the point of incidence. Suppose if it is a incident ray and at the point of incidence here, we will draw normal. But now observe here, this is the incident ray and this is the point of incidence. But how to draw normal here? And you know what normal is always which should be perpendicular to the reflecting surface. Okay, see, we at the point of incidence. So this incident ray itself, it is a normal. And what about reflected ray? Here, this line is also itself, it is a reflected ray. Here, in this case, incident ray, normal, and reflected ray all are lying on the same path. Okay. Now, what is the angle? Then, what is the angle of incidence and angle of reflection? Okay, that is angle of incidence is 0 degree and angle of reflection is also 0 degree. Okay, because the angle of incidence means the angle between incident and normal. Okay, so that's why it is 0 degree, and angle of reflection is also 0 degree. So next move to reflection of light in plane mirror. Reflection of light in plane mirror. Before that, you know about real image and virtual image. Oh, sorry. Okay. So, what are real image and virtual image? See, virtual images cannot be caught on a screen, okay, but whereas the real images can be caught on the screen. What is the meaning of these statements? It's so simple. Just imagine here this is a mirror, okay, this is a mirror and this is a object, say it is a candle, okay. Then take one screen means what? A sheet of paper. If you get the image of this object, if you get the image of this object on the screen, listen carefully, this is a mirror and this is a object, say candle or whatever it is, okay. If you get the image of this object on the screen, then we can say that the image formed by this mirror, is real image, okay. Clear? What is that? If the images are formed by mirrors, if you get the images on the screen, then we can say that those images are real images. If you won't get, then we call it a virtual image. Okay. So you studied reflection in your 8th standard. You studied the reflection of light in plane mirror. First, I will draw the diagram. Just imagine this is the plane mirror. Okay, this is the source. See, I'm taking two incident rays. Okay, incident rays at the point of incidence should draw normal, and normal is perpendicular to reflecting surface. So now this is the reflected ray, and this is also reflected ray. Okay. See here, after reflection, these two rays are they never meet. Okay, these two rays are never meet. Okay, but just observe here this side behind the mirror. Just try to exchange these lines. See, these two reflected rays are virtually meeting behind the mirror. Okay, clear? So so that's why, see, where two rays are meet after reflection, where two rays are meet, there we will get the image. But here, observe here, the rays are never meeting. Okay, but these two reflected rays are virtually meeting here. Correct? So that's why we won't get a real image in plane mirror, or we can say that the images are formed by a plane mirror are always virtual. Okay, so this is the first property of the plane mirror. Okay, what is the first property? The images are formed by a plane mirror are virtual and erect. The images are formed by a plane mirror. The images are formed by a plane mirror are virtual and erect. Okay, so this is the first property of the plane mirror. Okay, so you won't get a real image using plane mirror because here after reflection the rays are they never meet, right? But the reflected rays are virtually meeting behind the mirror. Okay, so that's why we won't get a real image. So this is the first property of the plane mirror. What is that? The images are formed by a plane mirror are virtual and erect. Okay, next, second one. See, we call this as a plane mirror. Just observe here, I am holding this marker in front of the mirror. Okay, just observe this size and marker size inside the mirror, both are same or different. Okay, suppose if it is 6 centimeter, then what is the image size inside the mirror? That is also 6 meter, right? So second property, it says that size of the object is equal to the size of the image. Okay. Size of the image is equal to the is equal to the size of the object. Size of the object. So this is the second property of the plane mirror. Okay. See, the size of the image is equal to the size of the object. This is the second property of the plane mirror. Next, third one. See, now it's a plane mirror and it's a marker. Now the distance between this plane mirror and marker is a 10 centimeter. See, now I will increase the, just observe the distance between the mirror and the image inside the mirror. Okay, so here 10 centimeter means in the size, the distance between size of the image and mirror also 10 centimeter, right? So now I will increase the distance. What about inside the mirror? The image distance also increases, right? I will reduce the distance. Here in the size, distance between the image and the mirror also reduces, right? If you increase, the distance increases. If you reduce the distance, the distance decreases. So the third property says that image distance is equal to the object distance. Third one, image distance is equal to the object distance. So these three are the properties of a plane mirror. These three properties are important for 2 marks. See, first revise the first property. The images are formed by a plane mirror are virtual and erect. Then second one, size of the image is equal to the size of the object. And third one, image distance is equal to the object distance. Okay? Yes. Next, move to reflection of light in curved surfaces. Just see how would the images be if the reflecting surfaces are curved. You might have experienced it in some places. If you stand in front of some mirrors, your body looks like very fat and thin, very tall and small. Correct, right? Because those are curved surfaces. Okay. Just imagine on circle. The surface, the curved surface of a shining spoon could be considered as a curved mirror. Okay. So now, this is a circle and this is a center. See, just cut here, here and here. Okay. Okay, see here. Now, if the reflecting surface is this one, okay, this one we call this is the reflecting surface. If the reflecting surface is curved inwards, means if the reflecting surface is faces towards the center, then we can call this as concave mirror. Concave mirror. Okay, now the reflecting surface is faces towards the center. Suppose if the reflecting surface is curved outwards, means this side. this side, then we can call this mirror as convex mirror. Convex mirror. Okay, see, just see the difference. If the reflecting surface is curved inwards, or if it faces the center, then we can call that mirror as concave mirror. And if the reflecting surface is outwards or away from the center, then we can call that mirror as convex mirror. In the curved ones, there are different types of the plano, concave, convex, and etc. But this year you are going to study the reflection of light in a concave mirror and convex mirror. See, before moving on to the reflection of light in concave mirror and convex mirror, we should know a few terms. Okay, first one. First one, pole of the mirror. Okay. See, now just imagine convex mirror. Okay. Now this is concave mirror. Concave mirror. Okay. See, actually this mirror, it is a part of a circle, right? So that's why it has a center C. So we call this a center as center of curvature. And observe here. So this is concave mirror. Okay. Now this is the reflecting surface. The exact midpoint of this mirror, is called pole of the mirror. Okay. The exact midpoint of the mirror, concave mirror, concave or convex, whatever it is. Or suppose if the reflecting surface is outwards, or we can draw like this. See, for convex mirror, we can represent pole of the mirror like this. Okay, because the reflecting surface is outwards, right? See, the exact midpoint of the mirror is called pole of the mirror. Okay, and this C is known as center of curvature. Okay, so now what do you call this distance from C to P? See, actually it is a part of a circle, right? This is a center. Now what we call that is radius. Okay, and this distance from C to P, we can call this distance as radius of curvature. Okay, next. Is over. Then second one, principal principal focus. Okay, and just imagine one is a concave mirror. Just imagine some rays are coming from at infinite distance. Okay, this is incident ray, this is center of curvature, and this is pole of the mirror, and incident ray. Okay, see, now these rays are striking the concave mirror. You know what happens when you pass the rays to the mirror? It reflects, right? So after reflection, all the rays are meet at this point. All the rays are meet at this point. All the rays are meet at this point. So this point is known as principal focus. Okay, what is principal? I think hope you understood what is principal focus. So now these rays are coming from infinite distance. Okay, so when the rays are from an infinite distance, after reflection, all the rays are meet at one point. Okay, that point is called principal focus. And you should know one more thing here. This point is exactly midpoint. It's not exactly, but we'll take it as we'll take it as this principal focus is midpoint between center of curvature and principal focus. Okay. So next, the third one, focal length. Focal length. Okay. See, the distance between the distance between principal focus, the distance principal focus to the pole of the mirror. Okay, the distance between principal focus and pole of the mirror is called focal length, and we use small f to represent focal length. Okay, the distance between principal focus to the pole of the mirror is called focal length. Okay, and to represent radius of curvature, the distance from C to P, we call the radius of curvature, right? We use R. Okay, you know, so now can I write this R is equals to 2 into F? R is equals to radius of a curvature is equal to the twice the focal length. Why? Because here, you know, this is the radius C to P. This is the exact midpoint between C to P. Okay, suppose if C to F is 2, say 5 centimeter, then what is F to P? That is 5 centimeter, right? 5 centimeter, right? So that's why the radius of curvature is twice the focal length. So that's why we can write the expression R is equals to 2 into F. Okay. Next we move to object distance. Object distance. See, now I will keep an object here. I will keep an object here. Okay. Now the distance between this object to the pole of the mirror, the distance between this object to the pole of the mirror is called object distance. And here we use small u to represent the object distance. Okay, clear? What is object distance? The distance between object to the pole of the mirror is called object distance. Okay. Next, suppose here I keep the object here, so I will get the image here. Just imagine I will get the image here. Okay. Now the distance between this image to the pole of the mirror, the distance between this image to the pole of the mirror is called image distance. Is called image distance. Image distance. We use a small v to represent the image distance. Okay. Next, see, observe here. You know, this line here we call this is C, and the exact midpoint between C and F is called the principal focus. Now, see this line, which connects center of curvature, principal focus, and pole of the mirror. Okay, we call this line as principal axis. Okay. Principal axis. Okay, see, now principal axis which connects center of curvature, or this principal axis, it passes through center of curvature, principal focus, and pole of the mirror. Okay, so we call this imaginary line as principal axis. And one more thing, see, this principal axis itself, it is a normal to the concave mirror, because if the mirror is like this plane mirror, so this is the incident ray. We can draw normally right at the point of incidence perpendicularly. Okay, but here in curved mirrors or concave or convex mirror, this principal axis itself, it is a normal. Okay, yes. See, these terms are very important. So just revise. First one, you have studied pole of the mirror, pole of the mirror. Second one, principal focus, and the third one, focal length. Fourth one, principal axis. Then image distance, object distance. Okay. Hope you understood these things. So I'll continue class tomorrow.